This side Anjali Singh, and I'm welcoming you to the platform of SchoolQuizz. Okay, so we are in the chapter that is motion. So we studied about the motion, okay, distance and displacement. After that, we studied about uniform and non-uniform motion, then about the speed. After that, we studied about in the last video, we studied about the velocity and some numericals which is related to velocity. And today is the date we will study about the acceleration. So I'll start my topic acceleration with the slide. Okay. So I'm sharing my screen. Yes. Now, here you can see acceleration is what? As I told you, velocity is the rate of change of displacement. Okay, rate of change of displacement means change of displacement with respect to the time taken. Change of displacement with respect to the time taken. That will tell you about the velocity. Or you can say distance in a particular direction. That is also the velocity. But here, when you'll talk about the acceleration, so the acceleration is rate of change of velocity. Okay, so like a body is changing its velocity. Okay, sometimes it will be changing means like it will increasing, or sometimes it will be like decreasing. Clear? So changing velocity means increasing means the velocity will got increased with a some rate, or decreasing means decreased with a some rate. Okay, sometimes the velocity will be constant means an object is moving with a constant velocity. There will be a no change in velocity. So I'll mark the definition that will be important here. Okay, so that will be like, yeah, here you can see acceleration of the body is defined as the rate of change of this velocity with respect to the time. Clear? And when you write in the formula change in velocity to the time taken for the change. Okay? Here change in velocity. What is the meaning of change in velocity? The change in velocity is always depends on final and initial. Okay, so it always depends on final and initial. So change in velocity means the final velocity as well as the initial velocity. Okay, the final velocity, which will be the greater velocity, and the initial velocity, which will be the smaller velocity. Sometimes it may get a final velocity will be greater, or sometimes it may be lesser also. Clear? So again, yeah, I'm removing it from a note. Then only it will start moving. So, yes, here you can see what it is. Final velocity minus initial velocity upon time taken. Final velocity is always represented by u. Okay, please keep in mind, final velocity is always represented by u, and initial velocity is always represented by u. Okay, and time, as you know, it is represented by t. So the acceleration is v minus u upon t. Clear? That is the acceleration of the body. Okay, so the acceleration means the change in velocity divided by time. That also you can say. And the most important, SI unit of acceleration. I want to, again, I'm going to annotate. So, yeah, acceleration, as I told you, what will be the formula? Acceleration is equals to change in velocity. Okay, so what it is? Sorry, change in velocity. Clear? Upon time. So the change in velocity, the formula of velocity is, we already studied, that is meter per second. If you don't know, so please see the third video. Okay, in that video, I already explained you about the how to find the unit of velocity. So the unit of velocity is meter per second and the unit of time is seconds. So this second will also go upside. So meter per second square. What it will be? Meter per second square. Clear? So yes, you can see meter per second square, meter per second per square, or meter per second square. This both statement is correct. So that is the student SI unit. That is what? SI unit. Clear everyone? And if we will talk about the unit, so kilometer per hour, kilometer per hour square, like centimeter per second square. So there are so many. Okay, now I'll choose the eraser. So, now, okay. So afterwards, we'll move towards the next thing. Uh, next is, we'll see the, okay, the most important line is, yeah, when a body is moving with uniform velocity. As I told you, when a body is moving with uniform velocity, or you can say the velocity is constant, this both statement is same. Body is moving with uniform velocity as well as the velocity remains constant. So in that case, the acceleration will be 0. Okay, in that case, suppose the car is moving and it acquires a constant velocity. It means it is moving with a 4 meter per second, or you can say, yeah, it's an example, 4 meter per second. So what? From the initial position also and as well as the final position also, it acquires 4 meter per second. Clear? So that is, in that case, the acceleration is 0. Again, I'll choose to explain you. Okay. Yeah. So where should I write? I didn't get a space. In that case, what it will be? In that case, acceleration is equals to v minus u by t. V minus u, final velocity. U is initial velocity. They are same. So either you write v is equals to u, they both are same, or you write u is equals to v. So v minus v, because they both are same, upon t. This will be 0 upon t. So the acceleration is also be 0. Here are some example. A car starting off from the traffic light or the green signal. So definitely the speed is changing in this case. In case of badminton also, you can see a ball being hit by a tennis racket. Both the ball speed and the direction is changing. Yes, it deals with direction also. Means the acceleration is a vector quantity. Okay, acceleration is a vector because here we are considering magnitude as well as the direction. That is why it's a vector quantity. Okay, I think in, yeah, here you can see this is a vector quantity. Okay, this is what a vector quantity. Clear? When the velocity of a body is not uniform, it's changing. So it means the motion is accelerated. Clear? When the acceleration will be 0, because when the velocity is not changing. Clear? See these two conditions are there. Okay, so again I am using the eraser option so that I'll clear the mess and move towards the next part. Yeah, about the uniform and non-uniform motion. So what is the, sorry, uniform and non-uniform acceleration? So it is as same as uniform motion or uniform speed. Here, when the acceleration is changing, when the, when the velocity is changing, when the velocity is changing in equal amount in equal interval of time. Means velocity keeps changing equally in a equal interval of time. So that is known as uniform acceleration. Clear everyone? That is known as uniform acceleration. When the acceleration is changing with in an equal interval of time, uniformly it is changing. The example is like a motion of a free falling body. That is the best example because it is a universal truth. What? That the motion of a free falling body, okay, it is an uniform motion. It touches the ground uniformly. Okay. Okay, here yeah, that we will see later. Velocity time graph. Okay, velocity time graph, or there are so many graph which is based on these topics that I'll cover in fifth video. Clear? So non-uniform acceleration. So what is this non-uniform acceleration? Non-uniform acceleration means the acceleration is not changing in equal interval of time. Okay, means the velocity is increasing, either it is increasing or not increasing. It depends, means sometimes it may increase, sometimes it may decrease. So here the velocity increases by unequal amount in equal interval of time. So that is the non-uniform acceleration. Clear everyone? So there the velocity is changing equally, it's changing. Here it's not changing equally, it's an unequal, it's changing in unequal amount. Clear? So yeah, I don't think here anything I has to write. Now the velocity time graph, you can see here, the velocity time graph for a body having non-uniform is a curved line, as I already shown you about the graph. So when you'll see the uniform graph, so that will always be a straight line. Clear? When we'll talk about the non-uniform, so it is a curved line. The line which is not straight, that will always be a curved line. Okay? And the next topic, that is a retardation or deacceleration or negative acceleration. Retardation means a body is said to be retarded. When the body is said to be retarded, when the velocity is decreasing. Okay, you can say decreasing acceleration also, but the proper word is given, that is a retardation. Clear? Retardation is measured in the same way as the acceleration. Yeah, it is a part of acceleration. But when you'll see the negative acceleration, means the acceleration is decreasing, that is said to be retardation. Okay? Or deacceleration. Clear? You can see here, yeah, again I have to go uh, with a knot. Okay, so here you can see the final velocity. I told you, no? What happened here? Yeah, here the final velocity. I told you, now that sometimes the final velocity will be lesser than the initial velocity in this video only. So here the final velocity is 0, means the final velocity is less than the initial velocity. So 0 minus 10, that will be minus 2. It means acceleration can be negative also. These points give you that acceleration can be negative also, and that is known as retardation or deacceleration. Okay, student, I think that is clear to you. Acceleration topic is over. So in the next video, I'll tell you about the graph. Okay, student. So stay healthy and stay safe. Goodbye.